Alright, so let's talk about 30, 60, 90 triangles. We've spent a lot of time on 45, 45, 90, and you're going to use a lot of the same concepts. So remember all the stuff that we talked about up here, how you multiply with square roots that happen to be the same to give you a regular number. The square root of 18, square root of 18 gives you a regular of 18, and so forth. Or you can multiply stuff that has different things under the square root, you just multiply them together. If you multiply things that are not under the square root, like this one, this 5, and this 3 here, they give you this 15, and you can't multiply it with the things that are under the square root. Remember all those facts that we discussed earlier. Okay, for 45, 45, 90s, we learned that you got the two legs that are the same, and whatever the leg is, you would times by the square root of 2 to get the hypotenuse. Okay, so a lot of times some books would just say it's a ratio of 1 to 1 to 1 square root of 2. This being a leg, this being a leg, and this being the hypotenuse. Okay, you can do it like that. I've always taught it as leg, leg, and then leg times the square root of 2. Now, when we're looking at 30, 60, 90, in a 30, 60, 90, one of the angles is 30 degrees, and the leg across from that angle is the smallest leg. It's the smallest side of the whole triangle, but it's a smaller leg. Then you got an angle that's 60 degrees. The leg across from it, this one, is a longer leg. So in 30, 60, 90s, you have one leg that's longer than the other. Okay, so got to keep that in mind. And the hypotenuse is always going to be the longest side. So this is the shortest side. This one's a little bit longer. This is the long leg. And this is the short leg. And then you got the hypotenuse. Okay, this is in a ratio of x for the short one. Then you got the longer leg, and then you got the hypotenuse. Okay, so x squared of 3, 2x. X squared of 3, a lot of people think regular 3, so they think like x, 2x, and 3x, and that's not the case. 3x would be bigger. Okay, but this is a smaller than the 2x. So one of the things you need to keep in mind here is that the short leg gets multiplied by 2 to get the hypotenuse. So this hypotenuse is always twice as big. And if you kind of look at this, you can kind of see like if there's a way I could swing this up here, it should fit right in the middle. Okay, so just something to think about. So that's the basic idea. Everything else is basically the same as what we learned earlier. Some books will list it as a ratio of 1 square root of 3, 2. So if you were to multiply by 2, for example, now you got 2 square root of 3, and 4. Or maybe you times it by 5. And so you got 5 square root of 3, and 10. Okay, so this thing here could be 5, and this would be 5 square root of 3, and this would be 10. So as long as all three sides get multiplied by the same thing, it really doesn't matter what number you multiply by. I've always taught it as long as you come up with a short side, everything else is based off of that. So you got the short leg, and you got a longer leg, which is whatever the short leg is times the square root of 3, and you get the hypotenuse, which is twice as the short side. 2 times the short. You can write it like this: 2 times the short, or short times the square root of 3. You just got to figure out what's the short. Sometimes it's given to you, sometimes you got to figure it out. Okay, so we use a lot of information we've already learned about before. So let's say here's a few examples. So all of these triangles are 30, 60, 90. I'm just not going to write 30 in each one of these, and 60 in each one of those, and 90 in each one of the corners. Okay, let's just assume they're all 30, 60, 90. So the short leg in this example is 3. As we talked about earlier, then that would mean that the short leg times the square root of 3 gives us the longer leg. So this is 3 square root of 3. And then the hypotenuse is always twice as big, so that's 6. Okay? Hopefully this makes a little bit of sense. I typically like to start with a hypotenuse if you're given a short leg, because it's probably the easiest one. The hypotenuse is twice as big, that's 20. The hypotenuse is twice as big, this is 10. Okay, and so forth. If this is the short leg, the longer leg is whatever the short one is times the square root of 3. The short one times the square root of 3. So this is 10 square root of 3. There's your answers. This is the short leg. This is a short leg times the square root of 3. And this is always twice the short leg. There's your answers. This is the shortest leg. This is the longer leg is the short one times the square root of 3. Now, since those happen to be the same thing as we talked about earlier, square root of 3 makes the square root of 9, which is just a regular 3. If these two repeat each other under a square root symbol, it makes that number without a square root. This is always twice as big in the hypotenuse as the short leg, so it's 2 times the square root of 3. This is a regular 2, this is a square root. You can't multiply those two things. One has to be under, they both have to be under square root, or they both have to be outside of square root in order to be multiplied. Okay, so the best answer we can get, sorry about the sloppiness here, is 2 square root of 3. That's it. That's twice the short leg. Okay, once again, you're given a short leg. The hypotenuse is twice as big. Okay, you can look at it as 2 times the short leg. This is the short, twice the short side. The whole numbers get multiplied because they're both outside square roots. They can get multiplied. It's 4 square root of 3. There's your short leg. You take the short leg and times it by the square root of 3. However, as in the last question, this makes a regular 3. So it's 2 times a regular 3, which means this answer is 6. Okay, kind of let that marinate in your brain a bit, trying to figure that out. Okay, here's the next question. Across from 30 degrees makes this the short side. The hypotenuse is always twice the short side, which makes this 8 square root of 3. Think about what the longer leg is going to be. It's always whatever the short leg is times the square root of 3. So 4 square root of 3 is the short leg, and we're times it by the square root of 3. So once again, square root of 3 makes a regular 3 in this example, which means it's 12. Okay. Hopefully this doesn't make a little bit of sense. I got a bunch more examples, but it's all just the same idea over and over. Okay, so here's the short leg. It's 5 square root of 2. You're going to do twice this to get the hypotenuse, 10 square root of 2. Okay, you do whatever the short leg is times the square root of 3 to get the longer leg. These two are both under square root. You can multiply them together. This is the square root of 6. 5 square root of 6, 10 square root of 2, and your short leg is that. Let's take a look at another one. This is the short leg. The hypotenuse is twice whatever the short leg is. Okay, so tell me what that's going to be. 12 square root of 5. You've got the longer leg here. It's whatever the short leg is times the square root of 3. Well, these two are both under square root, so you can multiply them together. Square root of 15. There's your answers. Next question. Think about it for a second. Okay, let's go with the hypotenuse first. It's always twice as big. 2 times 8 square root of 7. These are both not under square roots. That's 16 square root of 7. Oops, that should be 7. That's the hypotenuse. And you've got the longer leg right here, which is whatever the short one is, times the square root of 3. These two can get multiplied together because they're both under square roots. 8 square root of 21. There's your 3 answers. Now we're going to start with some other sides given to you to begin with. Okay, so let's assume you were told the hypotenuse. We know the hypotenuse is twice as big as the short, so 2 times some number gives you the hypotenuse of 20. Now you can make this a little algebra problem like I just did. 2 times the short side equals the hypotenuse. You would divide by the 2, because it's 2 times. To undo the times is division. Do it on the other side as well, and that means the short side has to be 10. And this is whatever the short side is times the square root of 3. Alright? We can just kind of look at it. You know this is twice as big as the shortest leg. So that means the shortest leg has got to be 5. This has got to be whatever the short leg is times the square root of 3. This has got to be twice as big as the shortest side. Whoops, I don't know why I put that. So this has got to be 2.5. And then 2.5 times the square root of 3 is the longer leg. Okay, so short leg, long leg is the short one times the square root of 3, twice the short leg. Still keeps working the same way in all of these. Okay, so work our way to a little bit more complicated questions. This is twice the short side. Okay, so some number had to be multiplied by 2 to end up with 4 square root of 3. Now you know that you can only multiply this by another whole number, can't be multiplied by a square root. So that square root's got to be square root of 3 in order to get the square root of 3 right there. What do we multiply? It's going to be 2. 2 times 2 makes the 4. So this has got to be the shortest leg. In other words, you can make it a little algebra problem if you wanted to. 2 times whatever the short leg is equals 4 square root of 3. And then you got to divide by 2 and divide by 2. And so that leaves you with the short being equal to 4 divided by 2, which is 2. You can divide them because they're both not under square roots. Just like you can multiply them, but they're both not under square roots. Okay, so the short is 2 times the square root of 3. The longer leg is 2 times the square root of 3 times the square root of 3. So whatever the short one is times the square root of 3. Just gonna go back up here to the original thing right there. Whatever the short one is times the square root of 3. Okay, so, but we've learned earlier that if you have repeating things under a square root, it makes a regular number without a square root symbol. So it's 2 times 3, which means the answer is 6 on this longer leg. So 6 is the long leg, the short leg is 2 square root of 3, and the hypotenuse was originally 4 square root of 3. If you were given this, kind of work it out, what would you do? You take this and times it by 2 to get this number, and you would take this times the square root of 3, and you get that number. Okay, so hopefully it kind of makes some sense. Cut this in half. What do you think the short leg is going to be? Because you have to take this times 2 to get the hypotenuse. So this has to be 4 square root of 3. What's the longer leg? Whatever the short one is times the square root of 3. Square root of 3 makes a regular 3. So cleaning this up a bit, we get 12. Okay, hopefully we're making progress. Cut the hypotenuse in half. Whoops, sorry about that. So you get, you get 3.5 square root of 3. That's the short leg. We take whatever the short leg is and times it by the square root of 3 to get the longer leg. This one. These two together make a regular 3. So this is 3.5 times the regular 3, and whatever this answer is your longer leg. So I don't know what that is. 9. It might be 10.5. Yeah, it's 10.5. Okay. Alright, so those two tend to be easiest when you have the short leg and you got the hypotenuse. It's when you're given the longer leg is when I get the most struggles from students. So remember, the long leg is whatever the short leg is times the square root of 3. And in this case, you ended up getting 4 square root of 3. So you got to kind of work backwards and figure out, well, what's the short side. Something times the square root of 3 gives you 4 square root of 3. Well, if you look at that long enough, you figure out that this something has to be 4. 4 is the short leg. Times it by the square root of 3, and you get 4 square root of 3. Hypotenuse is always twice as big. So I made that a little bit easier. Some people like to just go with a straight algebra problem and always do the algebra so that you're just doing step by step every single time. You don't have to think about anything. I'm not a fan of that, but if you want to, go for it. In which case your algebra problem is the short leg, and if you want to call it x, you can. And you're trying to get this by itself, so you're going to divide by the square root of 3. Divide by the square root of 3. In this case, the short equals 4. It will lead to some more difficult situations. You're going to have to do something called rationalizing the denominator. In some cases, you'll have to do that. But these are some easy questions to start with. So something times the square root of 3 gives you this answer. Okay, it will end up being this. We're looking for that something, the short side. Okay, if you want to call it x, whatever. I mean, make it an algebra problem, go for it. Gosh, dang it. I keep doing that by accident. But hopefully, once again, like the last question, you can just kind of look at it and see, oh yeah, this is going to be 8. Okay, so 8 times the square root of 3 makes 8 square root of 3. So the short side's got to be 8. Hypotenuse is twice as big. There's your answers. And as with the other two, it's the same idea. Something times the square root of 3 makes 10 square root of 3. It's 10. 10 is the short side. 10 times the square root of 3, and twice 10. Okay, it was x squared root of 3, and 2x. Remember that up here? The original thing that I showed you? Where's it at? Right there. Okay, is it starting to connect, or is it just making it more confusing? Alright, let's go with longer legs that don't have a square root of 3 in it. So something times the square root of 3, something times the square root of 3 ends up being 5 square root of 6. Like I said, you can make this an algebra problem, solve for your x, but this causes some issues for some people. In this case, x ends up being, because 6 divided by this, the square root of 6 divided by square root of 3 ends up being square root of 2, so it's 5 square root of 2. Okay, I like to just kind of think backwards. So you think backwards, you're like, okay, something times the square root of 3 gives me 5 square root of 6. This something, I can multiply square roots, so something times the square root of 3 makes the square root of 6, square root of 2. Well, where'd the 5 come from? You need a 5 there. 5 square root of 2 times square root of 3 makes 5 square root of 6 when you put them all together. And I know for some people they have a hard time thinking backwards like that, so you just kind of work your way or solve it through an algebra problem. That's cool. And then take this times 2 to get the hypotenuse, 10 square root of 2. Let's look at some more. If you made an algebra problem, something, this thing, the short leg times the square root of 3 would end up giving you 4 square root of 30. Okay, so maybe you're a person who can look at this and say, oh yeah, I know what I'm going to multiply this. What times the square root of 3 makes square root of 30? And you also have to have 4 in there. Whole numbers can't multiply by the square root, so you know it has to have a 4 in there. Okay, to me, I can look at this and I say 4 times the square root of 10, square root of 10, square root of 3 makes square root of 30. Can't multiply 4 times any of those, so that's why it's 4 square root of 30. If that's too difficult for you, you can make it an algebra problem where you just call this blank spot an x. Solve for the x by dividing by the number next to the x. If they're both under square root, you can divide these. That makes the square root of 10. Still got that 4 there, so, and this x is all by itself, so 4 square root of 10. And the hypotenuse is twice as big, 8 square root of 10. Because it's 2 times 4 times square root of 10. Both outside the square roots can get multiplied together. This video is starting to be kind of long, but hopefully it's making some sense to you. Okay, once again, what's this short side? Well, I need to have the short side times the square root of 3 to give me this longer leg. I keep saying short side, I should say short leg. I need to add the short leg times the square root of 3 to give me the longer leg. I can't figure it out, so I'm going to divide on both sides. This cancels this out, usually with x. Square root of 21 divided by square root of 3 makes the square root of 7. So this makes 6 square root of 7. This one is twice as big. That makes it 12 square root of 7. Here's your hypotenuse. Your two answers. Alright, so hopefully we're making some kind of progress. There are situations where this can be a little bit more challenging. I try not to ask too many difficult questions on your worksheets and whatnot. You'll learn more about this in future classes, but these are the basics. Alright, so sometimes the shapes are rearranged in some weird, I don't know if it's weird, but just in a different way to where you're not used to it. So just pay attention to where your 30, 60, and 90 are. Remember, across from the 30 is the shortest side. Across from the 60 is the longest leg, shortest leg, longest leg, and then the hypotenuse is always across from the right angle. Okay, so if this was told to you, you know the hypotenuse is twice the shortest leg. So that's got to be 5, and this has got to be 5 square root of 3. Okay, if I rearrange them in different orders, let's say this one over here, let's say this is the short leg, that means this one's going to be 30, this has got to be 60. Okay, so how about if this was the square root of 18? Then what are the other ones? That's a tough one. With whatever the short side is, that's the most important one. The short side had to be times by the square root of 3 to end up giving you the square root of 18. They're both or this is a square root in your result. You get a square root there in the problem. So something in a square root times the square root of 3 makes square root of 18. Hopefully you're figuring out that's a square root of 6. 6 times 3 makes 18. This is twice that square root of 6. Whole number can't be multiplied by stuff underneath its square root, so it has to be like that. There's a few examples. I don't know if this is going to help you out too much, but I'm trying. All right. I remember that there were some questions where you had some decimal answers, so maybe like this is 15, for example. The short leg, which is across from 30 degrees, is half the hypotenuse. Okay, so some people write 7/5. Some textbooks don't like decimals, so they might write it as 15/2, which is how you got the 7/5, right? And whatever the short leg is, you take it times the square root of 3 to get the longer leg. So I would take either 7.5 square root of 3, or some books will write this. Okay, now maybe you were thinking like 15/2 square root of 3. That's cool. Or you could write 15 square root of 3/2. This would be a common answer as well. This one is least common. This one would work. Because the decimal doesn't keep going on forever and ever, we'll be okay with that. If it was like a few decimal places or a very long decimal that went on forever and ever, then we would want to keep it a fraction like this. So occasionally we see something like that. So let's say you had this is the 30 degrees, here's a 60 degrees, so now you know where the short leg is. And let's say this hypotenuse, or let's go with this. Let's say that this is 9 square root of 3/2. Take a second and see if you can figure out the other two. We're getting close to the end of this video, so. And that would mean the short leg had to be something times the square root of 3 to get the longer leg. Well, that means it has to be 9/2, which is the same as 4.5. You want to call it 4.5, you can. If you want to leave it as 9/2, you can. It's 9/2 got multiplied by the square root of 3 here to get you this answer on the longer leg. And now the hypotenuse is whatever you take the short leg is times 2. So 2 times 9/2, remember 9/2 is just 4.5. So you're back to 9. Hypotenuse is 9. This is 4.5 or 9/2. And that's what you started with. Okay, there's a few examples. Hopefully that's enough examples to get you thinking about some stuff. Okay, so that's about it. Hopefully that helped you. All right, have a good day.